This is the video for Module 12, Section 7.2, about multiplying and dividing rational expressions. First, we'll talk about multiplying rational expressions, and recall that to multiply fractions, we multiply the numerators and multiply the denominators. Here's an example. If we're multiplying the two fractions, 3/5 and 8/7, all we need to do is multiply the two numerators together. So in the numerator of our new fraction, we have 3 times 8, and then we multiply the denominators together on the bottom. So in our denominator, we have 5 times 7. And then we just do the multiplication to get 24/35. Well, it works the same way with rational expressions. The one thing to be careful of with rational expressions is to be sure and use parentheses around factors when you have more than one term in a factor. Here's an example. We have two rational expressions, x over y and 2 over x plus 3. So we're going to multiply our numerators together. We have x times 2, and in the denominator, here's where we need to be careful and use parentheses around this second factor, the x plus 3. Because we're multiplying that whole factor times the y. So we can rewrite this in a little bit more standard form. And in some places in your homework, they're going to expect you to distribute, so they might want you to multiply the y through into both of these terms. But here we're just going to leave it in a factored form. So we'll leave this as y times the quantity x plus 3. The other thing we need to think about when multiplying fractions or rational expressions is that the results of the multiplication should be written in a simplified form. So we're going to look at some steps for multiplying two rational expressions together. The way we're going to do this will end up with our answer in simplified form. So the first step we're going to do is to factor the numerators and the denominators of all of the rational expressions. Then after we've factored, then we're going to multiply the numerators and multiply the denominators, just like we did in the two examples. And the third thing is to check and make sure that our result is simplified. So we're going to make sure that all common factors have been canceled and that our result is written in lowest terms. So we can write out these three steps in sentences like this, or we can think about just the three main words. So the factor, multiply, and simplify. If you can remember those three words, it'll help you. Here's an example. So we're going to multiply 8p minus 8 over p times 7p squared over p minus 1. So the first step we're going to do is to factor everything that we possibly can. So we're going to look at each numerator and each denominator and see if anything can be factored. Well, in this first numerator, 8p and 8 have a common factor of 8. So we're going to factor that out. So there we're going to have 8 times p minus 1. In the denominator of that one, we don't need to do any factoring there. In our second rational expression, there's nothing that we need to do here as far as factoring either. So that was our first step. Now our second step is to actually multiply. That means we're going to put the numerators together. So we have 8 times p minus 1 times 7p squared, all in one numerator. And we're going to multiply the denominators together. And here again, we need to use the parentheses around the p minus 1. For one thing, that way we can tell it's actually a factor. So that was our second step, just to write our numerators together and our denominators together. And our third step is going to be to simplify. And that means that we'll look for any factors that the numerator and denominator have in common. For example, there's a p minus 1 in both that we can cancel. And we also have a factor of p in both the denominator and the numerator. So we can cancel, here we have a p squared, here we have a p. So we can cancel out a p. And that will actually leave us in the denominator with no factors left. Remember, we do actually still have a 1 there. What we have left in the numerator is 8 times 7p. In the denominator, we just have 1. So our last step now is going to be to rewrite this so it looks a little bit nicer. Since we have the 1 in the denominator, we don't even have to write that, and we can just write our answer as 56p. Let's do a couple more examples, and let's remember our 3 main steps that we're going to do are factor, multiply, and simplify. So first, the factoring. In this first example, again, in the first numerator, we can factor a 2 out of each of those terms. So we have 2 times x minus 1 over x. And then in our second rational expression, on the top we have our 3x squared, and in the denominator, these two terms have a common factor of 5. So if we factor the 5 out, then we have x minus 1 left. So we're all done factoring. Now we're going to multiply. So again, we're just going to write all of these factors in one numerator and all of these factors in one denominator. Now our last step is to simplify, so we're looking for common factors. We have an x minus 1 factor in both. We have an x in both the numerator and the denominator. So here we're going to cancel out one of our x's, and here we're going to cancel out this whole x. And we have a 2 and a 3 here and a 5. Those numbers don't have any factors in common. So we're all done with canceling. So what we have left is a 2 and a 3x on the top, and in the numerator we only have a 5 left. So we've canceled out every factor that we had in common, and we just have one more step to rewrite this in a little bit nicer form. So we'll multiply the 2 and the 3 to get 6x in the numerator and 5 in the denominator. Okay, one more example. This one we have a little bit more to do as far as the factoring goes. In our first numerator, y minus 3, we can't do anything with that. In the denominator, notice we have y squared and 36. Since 36 is 6 squared, that means we have the difference of squares here. So we can factor this as y plus 6 times y minus 6. And notice the important thing about factoring first is that we're not looking to do any kind of canceling. If you start out in a problem like this trying to cancel things, you're just going to get into trouble because you'll end up trying to cancel terms instead of factors. And we already talked about, in the last section, we talked about the fact that you can't cancel terms, you can only cancel factors. Now for the second numerator, since this is a trinomial, we're going to factor it into 2 binomials. So since we have a y squared here, then we're going to have a y in each of our binomials. And I'm going to copy this first sign into the first binomial here. And then since the second sign here is a plus, that means that both of these have to have the same sign. So that means we have to have 2 minuses. We already had a minus here, and that means we have to have a minus there. So what that tells us is that we need 2 numbers that multiply to 30 and that add to 11. So if we think about numbers that we can multiply to get 30, there's 3 times 10, 2 times 15, 6 times 5. Oh, and 6 plus 5 is 11, so we've got our answers there. And remember, if you're using this method with the signs, just put the bigger of the 2 numbers in the first binomial. So we end up with y minus 6 times y minus 5. and we don't have to do anything for factoring the denominator. So now we've got all of our factoring done. Now we're going to do the second step, which is multiplying. And here, since our y minus 3 is a factor, we're going to put that in parentheses when we actually multiply our two numerators together. So we have y minus 3 times y minus 6 times y minus 5 in the numerator, and y plus 6, y minus 6. And again, our factor in our second denominator, we're going to put in parentheses so that we know it's a factor. So that's our multiplying step. Now we want to simplify, so we're just looking for factors that are in common. So we have a y minus 6 in both of these. We can cancel that out. Now we don't have any other factors that are in common between the numerator and the denominator. So that's all we can do as far as simplifying. And in some problems in your homework, the directions will tell you to leave your answer in factored form, which would be just like this. In some of them, they will tell you to go ahead and multiply out the factors. So this is left in factored form. And that is our final answer because it's completely simplified. Now we're going to look at dividing rational expressions. The only difference between dividing and multiplying rational expressions is that we have one extra step for division. And that is that we first have to change the division into multiplication by using the reciprocal of our divisor. And another way you might have heard about this in other classes is to invert and multiply. So we take the second fraction or rational expression, invert it, in other words flip it over, and then that turns the problem into a multiplication instead of a division. Let's look at this first with two fractions. If we have 6/11ths divided by 5/33, then to do this division we're going to first change it into a multiplication. So we're going to take our second fraction here and just invert it or flip it over and make it 33/5. And that changes this from division into multiplication. Now once we've done that, we have the same multiplication, the same type of multiplication problem we just talked about. So we can multiply our numerators and multiply our denominators. Since here we're just dealing with numbers, right here we can look for any factors that are in common. For example, 33 and 11 both have a factor of 11, so we can cancel out the 11. That leaves us with a 3 here and cancels out all of the 11 there. And then we have 6 times 3 on the top and 5 on the bottom, so there are no other factors in common. So we would multiply the 6 and the 3 and get 18, and in the denominator we would have 5. Now let's look at this with some rational expressions. So again here our first step is going to be to change this division into multiplication. And our first rational expression here is not going to change at all. We're just going to rewrite it. The second one, in order to change this into a multiplication, we're going to take this second one and invert it or flip it over. So now on the top we'll have 12k to the 6th. On the bottom we'll have 16k to the 4th. Now we're just back to a multiplication problem. So we have our 3 steps of factor, multiply, and simplify that we're going to go through. Now there's nothing to be done here as far as factoring, so we can actually go right to the multiplying step. So in our numerator we have 4k squared times 12k to the 6th. In our denominator we have 9k to the 5th times 16k to the 4th. There's our multiplication. Now we're looking to simplify. So we're going to look at the numbers and see if there are any factors in common that we can cancel, and then we're going to look at the powers of k and see what we can cancel there. Let's look at the numbers first. So if we look at the 4 here and the 16 down here, we can cancel out a 4. And remember that we can do this because everything in both the numerator and the denominator is multiplication. There's no addition or subtraction. So everything that we see in here is a factor instead of being a term. Okay, now let's keep looking. The 12 and the 9 both have a 3 factor, so we can cancel that out. If we cancel that out of the 12, we have a 4 left, and if we divide 9 by 3, we have a 3 left. And one more thing, now we have a 4 in the numerator and a 4 in the denominator, so we can cancel both of those. Okay, let's write what we have left. So we still have that negative out in front, and we canceled out all of the numbers that were in the numerator. In the denominator, we still have a 3. So we have 3 times k to the 5th times k to the 4th. So now we're just looking at the k's to see what we can cancel. And here we can cancel a k squared with our k to the 5th down here, and so we would still have k to the 3rd left here. And here we can cancel 4 of these k's. So we'd have a k squared. We're canceling all of those. And now we have k squared here and k to the 3rd here, so we can cancel out 2 of the k's. And that leaves us with nothing in the numerator, so we need to write a 1 in there. And we canceled out 2 of these k's, so we just have a k left in the denominator. So that leaves us in the numerator with a negative 1, in the denominator with 3k. And that is our simplified answer. So again, once we've taken our division problem and turned it into a multiplication problem, we're just using the same steps we used before: factor, multiply, simplify. Let's do another example. So here we've got a division problem. It's always important to look and see whether this is multiplication or division to start with, because if it's division, you have an additional step, and that is to turn it into multiplication. So in fact, we can add a step to the beginning of this if we have a division. So our first step here would be to invert, meaning take our second rational expression, invert it, and that turns it into a multiplication. So now really we have 4 steps: invert, factor, multiply, simplify. And that first one has to be the invert part. So we're not doing any factoring yet. We're not doing anything except rewriting this so that it's a multiplication problem. Again, to do that, we're just taking our second rational expression and inverting it or flipping it over. Okay, so that was the invert part. Now we can start factoring. So for our first numerator, x to the 3rd and 4x squared both have an x squared. So we're going to factor out that x squared. When we do that, what we have left is an x from the first term and a minus 4 from the second term. For our first denominator, we don't have to do any factoring there. In our second numerator, those two terms have a 5 in common, so we're going to factor the 5 out, and what we have left is x squared plus 1. And then in our second denominator, notice that we have 16, which is the same as 4 squared, and then we have minus x squared. So this is the difference of squares, so we would factor that as 4 plus x times 4 minus x. Now, one more step to do before we do the multiplication part. In the last section, we talked about looking at opposites of expressions. In this one, we have an x minus 4. Down here, we have a 4 minus x, and those are going to be opposites. So let's rewrite this one as negative 1 times x minus 4. That's going to help us when we get to our simplification step. So now we'll take all of those factors from both numerators and both denominators and multiply them together. So in our numerator we have x squared times x minus 4 times 5 times x squared plus 1. In our denominator, we have 5x times 4 plus x times negative 1 times x minus 4. One thing I should mention before we go on is that we didn't try to factor our x squared plus 1 anymore. The reason for that is because we do have an x squared and 1, which we could write as 1 squared, but they're added together. We could only factor these if there were a negative here so that we had the difference of squares. But you can't factor the sum of squares, so there's nothing more that we can do to factor this particular factor. Now we're looking for factors that are in common. So notice we have the x minus 4 on the top and the bottom. We have a 5 in both places that we can cancel. And here we have an x squared and an x. And notice again that these both count as factors because they're multiplied times other factors. There's no addition or subtraction with another number here. So these count as factors, and that means we can do some canceling. So we're going to cancel an x, which just leaves an x here, and we're going to cancel that x down there. So what we have left is an x, and then this term, this factor, the x squared plus 1. In the denominator, we canceled the 5 and the x, so we have the 4 plus x. And remember that addition is commutative, which means we can write this in either order. So we could write this either as 4 plus x or x plus 4. Let's go ahead and write it as x plus 4. And then we have the negative 1 left. Now let's check and make sure that there aren't any other common factors that we've missed. There isn't anything else that these have in common. Now this negative 1, we can actually write it out in front here, and we could put it in any one of 3 places. We could put it as a negative in the denominator, we could put it as a negative in the numerator, or we could put it all the way out in front of our rational expression. So let's write it that way with the negative all the way out in front. So we have the opposite of x times the quantity x squared plus 1. And on the bottom now all we have is the x plus 4 because we took that negative 1 and moved it all the way out in front. Now you can only do that with a negative 1. If it were a negative 2 or some other number, we wouldn't be able to get rid of it that way. But here is our final simplified answer. Okay, one more example. This one, it looks like we are going to have to do a lot of factoring. But again, our first step is to invert so that we turn this into a multiplication problem. So we have our first rational expression, which doesn't change. And then we're making this a multiplication, and so we're taking our second rational expression and just flipping it over. So we have 2y minus 6 on the top and y plus 1 quantity squared on the bottom. Now that we've done the inversion, now we just have a multiplication problem. So now we're going to do all of the factoring. And notice in this first numerator, all of these terms have a factor of 2. So let's start just by factoring out the 2. That leaves us with y squared plus 4y plus 3. And let's look now at what we can do on the bottom. We have y squared minus 9. Since 9 is 3 squared, that means we have the difference of squares. We can factor that as y plus 3 times y minus 3. And in our second numerator, we have 2y minus 6. Those both have a factor of 2. So let's factor out that 2, and that leaves us with y minus 3. And in the denominator, this is actually already factored. Now we have one more step to do, and that's going back to this first numerator. We have a trinomial, so we need to try and factor that into 2 binomials. Don't forget to keep your 2 out in front. Now since we have y squared, that means we're going to have a y as our first term in each binomial. We're going to copy this sign into our first binomial. And then since our second sign is a plus, that means that both of these have to be the same sign. So that makes this a plus also. Now we're looking for two numbers that multiply to 3 and add up to 4. So the only two numbers that we can multiply to get 3 are 3 and 1, and 3 plus 1 is 4. So those are going to be our two numbers. We're going to put the biggest of the two in our first binomial. So we end up with 2 times y plus 3 times y plus 1. In the denominator, we still have our y plus 3 times y minus 3. And our second rational expression, we've already factored, so we're just going to leave that the same. Okay, now we're ready for our multiplication step. So we're taking all of the factors from both numerators and just writing them together. So we have 2 times y plus 3 times y plus 1 times another 2 times y minus 3. And in the denominator, we have y plus 3 times y minus 3 times the y plus 1 quantity squared. Okay, there's our multiplication step. Now we want to simplify. So that means that here we're looking for factors in common. So I see a y plus 3 in both places that we can cancel. And we have a y minus 3 here and here that we can cancel. And notice we have a y plus 1 factor here and a y plus 1 quantity squared factor here. Now remember, if we're squaring a whole quantity, that's the same as having it written twice. So this is the same as y plus 1 times y plus 1. And that means that we can cancel one of those. So we're going to cancel this one in the numerator with one of these in the denominator, and that'll leave us still with 1 in the denominator. So what we've got all together now is this 2, and we've got another 2, and we canceled all the rest of the factors in the numerator. In the denominator, the only thing we have left is y plus 1. So if we go ahead and multiply the 2's together, we end up with 4 over y plus 1. All right, here's another example. So again, our first step is to invert our second rational expression. So that makes this a multiplication. And for our second rational expression, we end up with v minus u over u. Now we're going to do our factoring. Our first numerator, there's nothing to be done there. Our first denominator, since we have u squared minus v squared, this is the difference of squares. So we can factor this as u plus v times u minus v. And for our second rational expression, there's nothing we can do there to factor either. And again, notice that in this step, we're not doing any kind of canceling. Now we can go ahead and multiply. So in our numerator, we have negative 4 u squared v times, and since the v minus u here is the whole numerator, that's a factor, so we do need to write it in parentheses. And in our denominator, we have u plus v times u minus v times u. Now we're looking to simplify this, so we want to find any factors that might be in common. And again, if you notice here, on the top we have a v minus u, and on the bottom we have a u minus v. Those are opposites. So we could rewrite this v minus u as negative 1 times u minus v, since it's the opposite of u minus v. And then you can see that we could cancel the u minus v. Now the other thing that we can cancel is that we have a u factor here, since it's multiplied, and a u squared factor here, so we can cancel out one of the u's. Now let's see what we have left. Oops, it's hard to tell that got canceled. So what we have left in the numerator is a negative 4uv, and we also have the negative 1 that we had up here. In the denominator, all we have left is u plus v. So now to finish this, notice in our numerator we have a negative here and a negative here that are multiplied together. So if we multiply those two negatives, that'll just give us a positive. So we just end up with a positive 4uv over u plus v. Now that's the end of section 7.2. Now you can go to MyMathLab and work on your homework for that section.